Right, hi folks, this is a Triton machine that we picked up. It was a machine that was bought brand new and used once or twice, and it just stopped working. The motor wouldn't start up. Checked all the electronics on it and found that there is definitely an issue with the electronics. It's not starting the motor up. You can hear it buzzing, so there is energy going to the armature and to the motor, but it's not rotating, so we need to establish why. So this is a Triton TSPS450 oscillating spindle sander, and what we're going to do is we're going to try and see what we can find is wrong with the machine and see if we can repair it. So yeah, let's get on with the job and see what we can find. Right folks, so we've stripped the machine down now to try and see what we can find as being the issue. As you can see, we've got everything out, the oscillating mechanism and the mounting for the drive motor, and then of course the stator and the armature here. So the motor is stripped, and I'll get into what we found here. But first off, what I want to do is just show you the different components that we've got that came with the machine. So of course, this being an oscillating drum sander, we have different size drums that we can stick onto the machine, onto the shaft here, and depending on the size of drum you use, you obviously change the inserts that fit into the top of the deck of the machine. So pretty simple machine, easy to use, really nice machine when it works. So yeah, what we found is, initially I thought that there is going to be a problem with the control board, maybe one of the capacitors or one of the resistors, or even the printed circuitry may be damaged. So I went through the entire circuit board, tested the circuitry, everything seems fine, everything is intact, nothing has got any issues here, so that definitely wasn't the issue. So that's good. So that then led me to then move on to, okay, from there, why is the motor not running? So the next step was, for me, was to try and establish, have we got issues with the brushes? You know, is there a wire broken within the brushes? What can I find? The brushes look really good. Obviously the machine is very new, it's never been used much, so the brushes are all good. I tested the continuity on the housing of the brushes and the end of the brushes. We're getting good current flow through there, so it's certainly not the brushes, which then led me to then have a look at the armature. Right, so what we can see here is what's caused the issue with the motor. The motor's been running periodically every now and again, but what we found is that the armature windings, where these wires make contact, they loop through this area here, and then it's crimped down. It's been over crimped, and what's happened is it's actually cut the wires off. So out of all the contacts that we have here where these wires join, most of them are broken off. So we can see another one here. If I rotate, you can see another one here is gone. So all the ones that I've marked in black are broken. So there's only 2 out of all of them that are still intact. The rest are broken off. So how this thing was actually running when it did run, I'm not entirely sure. But anyway, so this is the reason that's caused the motor to not work and the failure of this machine. It's a brand new machine, so quite surprised that this is an issue, but nevertheless we're going to replace the armature, and we'll give you a rundown as how we do that. Right guys, so we've got the new armature. It's arrived now, so we're going to unpack it or unbag it here, and we can show you exactly what we see. We bought this off eBay, very reasonably priced, round about between 18 and 20 pounds for the armature, which I think is a really good price for what it is and for what it does. Literally the heart of the machine. So rather an inexpensive part to replace. And I'll put the link in the description below as to where you can find parts for this machine. This company that we bought this through on eBay does a wide variety of parts for this machine and other machines alike. Right, so let's have a look and see what we've got here. Make sure that they are the same. So looking at the initially looking at the length, they are exactly the same. The armature diameters are the same. The fans are the same. The position of the fans are the same. Obviously, the new armature doesn't come with the bearings on it, so I've also ordered the bearings. So here I've got end-to-end bearings, and the bearing numbers, if you're interested, is, let's have a look here. We've got 6001 2RS, and we've also got 608 2RS as well. These are high-speed running bearings with rubber seals, perfect ideal for this machine. So we'll assemble the armature, put the bearings on, and then we'll begin to assemble the motor. Right, so we're going to assemble the bearings onto the motor now. One thing I'd just like to point out to those of you who may be interested, in order to find the correct bearings, each bearing has got a unique number, which relates to the dimensions of the bearing and the type of bearing, whether it's a high-speed bearing, whether it's an axial load bearing or not. So on the seals of the bearing, you will find the number is written there. That's a generic bearing number that you will find on all bearings, and with the exception of certain types of bearings that will be unique to that particular manufacturer, generally the bearings will have a universal number which crosses over different brands. So at the moment we're using NTN bearings, really good quality bearing, very good company, very, very good bearings. Right, so let's move on to putting on the first bearing. I'm going to assemble the small bearing on first, and then we'll follow on with the larger bearing on the top end of the armature. Alright, so here we have the bearing we're going to put on. It's always a good idea to just put a little bit of lubrication on the shaft, just to help the bearing just to seat down, so that there's not too much resistance. So I've got a little bit of general purpose grease here, which I will stick onto the shaft here and get it lubed up. Not too much, because you don't want it to be spraying out everywhere. I'm going to put a little bit on the front of the shaft where the other larger bearing runs, and that will just help it lubricate to seat as it presses onto the shaft. Get it lined up as close as you can to being square with the shaft, and we will just tap it on just gently, just to get it to start off. Alright, so now we've got the bearing lined up on the shaft, and now we need to press it down home, or knock it down home. Unfortunately, I haven't got a press available right now, but we'll be using a hammer and being very gentle with the hammer. Right, so I'm going to use a nice flat punch with a clean flat surface, and we will just gently tap this down until it reaches its seat. We just check and make sure. Okay, we've got about 3 mils to go. Now you want to do this gently so you don't damage the shaft, or damage the shaft going through the windings on the armature. So you'll know when it's seated when you get a nice solid thud through the pin and through the hammer. Right, so that's the bottom bearing in position and in place. Check to make sure that it rotates freely, got no resistance, got no rough feeling to the bearing. That will give you an idea that nothing has been damaged or compromised on the internal components of the bearing. Alright, so we're now going to assemble the larger bearing on the front end of the shaft. Question that we may have is, how far do you press the bearing down onto the shaft to ensure that it fits into the motor correctly at the right position? And if you look closely, what we will see down here is you will see that there is a little groove that's cut and machined into the shaft here. So basically what you want to do is you want to press the bearing down until the bottom end of the bearing is flush with the top of the groove, and that will give you exact position for pressing your bearing down. To not apply force or hammer on the outside of the bearing, because you could damage the internal components, because you know it's putting a lot of stress down onto the bearings and the cage on the inside. But unfortunately I don't have the right tools. It's not the right way to do it, but I will be doing it very, very gently and checking the bearing periodically to make sure I haven't caused any damage. So we will be using a tube socket here that will be the same diameter as the outside of the bearing, and because of the length of the shaft I need a tube socket, and so let's get going. Let's put this on and see how we get on. So we slide the bearing down the shaft. It goes down. There is obviously a difference in the diameter where the bearing seats to give it that sort of press fit. So let's give it a gentle tap and start getting it down into position. So let's just check. As you will tell, I'm doing very gentle taps, nothing hard, nothing forceful. Is going down. The bearing is going down nicely. Now we just need to check as we're going down to make sure not too much further to go, and there we are. So the bearing is on and it still feels perfect and no damage caused. Excellent. Okay, so let's begin the assembly. So the first thing to do is to assemble the armature into the stator of the motor, and what you'll notice is inside here there are some fairly strong magnets, and it can be quite difficult to get this in, but please be careful that when we slide the armature in we don't damage the armature in any way or chip the magnets as we're sliding it in. So just hold a little bit of resistance and tension and let it slowly guide itself in. As you can see, it's beginning to start pulling, and it will slowly pull itself in, as you can see there. Right, so now we need to check and make sure that the bearing has seated completely into the base of its seat here, which it has, and there's the armature seated in. The next thing is now to mount it onto the actual oscillating housing, and this is what's going to drive the rest of the mechanism. The area is cleaned, everything here is clean. So let's go ahead and assemble it. Right, let's get the bearing in, make sure we slot it in, and make sure it's seated. Right, let's put the screws in. There are different length screws, so always make sure you have the right length screw so they go in the right locations. It's always a good idea to tighten them opposing, just to make sure that it pulls it down evenly and you don't end up cracking the plastic housing. Right, we won't tighten it up just yet. We'll just make sure that they all seat first before we start applying too much tension and pull the motor all the way home. And just do one last final check. Don't over tighten them because they do screw into a plastic housing, so you don't want to strip the threads out of the plastic housing. Just make sure that they're seated and the motor's firmly affixed to the oscillating mechanism. Right, now that the motor is in position and nicely fixed to the oscillating housing, the next step is to then mount the control unit, which controls the motor. And these two wires, these two black wires, one goes to each of the brushes, one on either side of the motor. This is your grounding strap, and then these two here come from your switch mechanism on the housing. So let's go ahead and let's put this one on. There's two little screws that mount in here. Can be a bit finicky. so let's put the earth strap on next. Small little screw that goes into the motor housing. Always important to make sure you have a good ground, otherwise that can also cause an issue. Right, so the next step is to mount the brushes. An important thing to note about the brushes is there is a two little steps within the casing here, and this little cover clips into that, so you can only put it in one way. Obviously if you do it the wrong way it won't fit, so let's go ahead and locate it. You're going to put the brush gently against the armature and then just gently lift it up, slide it forward and locate the dowels which are in position. You may need to just use a little flat screwdriver just to hold the brush in position, otherwise it might jump up and pop out. And then there is a plastic retaining cover that you just slide down over, which will keep it all in position. So that's the first brush on, and now we will mount the brush down and the cover down with these two screws. Right, that's brush 1 done. So now let's move on to brush number 2. It's nicely seated in there. That one's staying so we don't have to hold it with a screwdriver. Gently slide the cover over. And let's mount the screws. And as you can tell, it is quiet, it is very smooth, no resistance from anywhere. It means that the bearings have located correctly, lined up correctly, and the brushes are running nice and level with the pads on the armature. So far looking really good. Next step then is to attach the wires to the brushes. So I'm just going to lift the motor and push the wires onto the brush contacts. Make sure that your insulator is properly seated over the terminal. And there we go, it's connected and in. Right, now that the motor is mounted to the oscillating mechanism, the next step was to put the belts on. I did this off camera. It is a little bit finicky to get the belts on. And I actually, to be honest, forgot to record me putting the belts on, but in any event, quite simple. Make sure that your belts are aligned onto your cogs on the oscillator mechanism, and then slide your belts down over the drive cog on the motor. There is a tensioner here, and the tensioner is for the smaller belt below, and the reason for that is that the tensioner creates the belt to be slightly shorter than the top belt, which causes the cogs to run at different speeds, very slightly different speeds, and that's what allows the oscillator to actually to rotate up and down. So I will show you in a bit more detail a bit later on as to how this oscillating mechanism actually works. But the first thing we're going to do is we're going to just tension up this belt. Here's a little idler tensioner here, and that's going to locate up against the belt. So let's go ahead and put that in position. Get the first screw in. Once the first screw is located, it makes it a lot easier to then get the tension on the belt. Obviously don't tighten this too tight just yet, because you need to be able to have some free movement. And then put the rest of the screws in. The last screw is right at the back, quite close to the oscillating mechanism, so you need to lift this up slightly just to be able to get your screw in. can be a bit difficult to get in there. There we go, screws in position. I just need to lift the mechanism to get the screw underneath the drive. Right, there we go, the tension is in position, belts are all in position. Now we just need to rotate and make sure everything's running free, nothing's binding, and the belts are running true as they are, and that is looking very good. Right, so we are ready now to assemble, putting the motor and the mechanism back into the casing and housing. So let's get on with installation of the motor. Make sure it's seated nicely in the base, and then let's put all the screws. Right, screws are in position, let's tighten it up. The motor is nicely secured into the casing. Now it's just a case of just connecting the wires to the power switch. There we are, that's all done. Make sure everything else is in position. Connect the main power feed. There we are, that's in. Now comes the cover. Right, so let's plug it in and let's do it for its first test and see how we got on. Right, power's plugged in. Here we go. Let's see. Beautiful, perfect. So now let's mount one of these drums on and let's see how we install that. Get the right plate for it. Right, here we go. We're going to test it out on this piece of timber here. It's a handle for a fishing net that we're busy manufacturing. So let's have a look, see how it works. Well, there you have it, guys. Perfectly functioning machine that was previously destined for the skip, and we managed to save this motor, or this machine, and by just simply having a look to see what's wrong with it, we were able to repair it for a little bit of my time and about £20. So there's a good win, and thanks very much for watching. And if you're interested in watching more of our videos, subscribe to my channel and hit the like button if you want to get notifications so you don't miss any of our future videos. Thanks very much for joining, and we'll see you on the next one. Thanks, guys.